In this video, we're going to look at position vectors as a function of time. All right, so let's say we're given the position vector r equals 5 minus t in the I direction, parameterized in terms of t, sine t in the j direction. Okay, t belongs to the positive reals union 0, which is another way of saying that t is equal to or greater than 0. Now, at different times, don't forget to set your calculator in radian mode when we do this. So make sure it's in radian mode when you evaluate these. Okay, 5 minus t, let's say t is 0. Well, 5 minus 0 is 5. I, sine of 0 is 0. And so we just, its position vector is at 5i. It lies along the x-axis at x equals 5. Okay, at t equals 1, put 1 in there. 5 minus 1 is 4 in the I direction. And then sine of 1 in the j direction. I'm not going to put that here because it just gives me an approximate answer. Same with the rest. At t equals 2, 5 minus 2 is 3i, sine of 2. Okay, and so on up. Okay. The Cartesian equation now is given by the position vector as a function of time is some x as a function of time. Okay, x is a function of time. And my pen's too thick for that. I shall be changing that. Okay, I'll put t in there, y of t in there, and so x is 5 minus t, x is 5 minus t, t is 5 minus x, just rearranging that, y equals sine t, so where the t is we can put 5 minus x, and the Cartesian equation becomes y equals sine of 5 minus x. Okay, now let's have a look at a motion of two particles is given by the vector equations. The first particle has position vector r1 at 2 minus t in the I direction, 3t in the j direction, and particle 2 has position vector as a function of time, t squared in the I direction, 2 plus t in the j direction. Okay, the particles collide when both position vectors are equal to each other, and then we just need to find at what time or times does this occur. So set the two position vectors equal to each other, okay, and equate the like coefficients. So 2 minus t for the first I component must equal the first I component of the second particle's position vector, t squared. So 2 minus t is t squared. Okay, we can solve that. T squared plus t, taking t over here, minus 2 is equal to 0. Factorizing that, we have t plus 2, t minus 1 is 0. Let's look at the other side now, the other component, sorry. 3t here is equal to 2 plus t. Okay, so let's subtract t from one side, from the right there, and from the left. So we have 2t is equal to 2, t is 1. Both solutions, the solution can only be where both the values agree. And so t equals 1 is the only possible solution, okay, because both agree on that. So the only solution is t equals 1. At t equals 1, the position vector for both is I plus 3j. Simply substituting t equals 1 into both just to check. So 1 squared is 1, 2 plus 1 is 3, so 1i plus 3j. Same over here, 2 minus 1 is 1, 3t, 3 ones are 3, so 1 plus 3j. Okay, so that's the point where they coincide, where they collide. The distance between the two particles at t equals 10, well, we need to find the position vectors at t equals 10. So for the first one, we get, put 10 in there. You have 2 minus 10 is minus 8i, 3 tens are 30, so minus 8i plus 30j. For the other particle, put 10 in there, so 100i, 10 plus 2 is 12j. Okay, now, what we need to find is the distance between them. We need to find the displacement vector from one particle to the next. So let's say we'll take R1 at 10 minus R2 at 10. Okay, and when we work that through, we are going to get, you could do it either way, you'll just get different signs here, not that it's going to matter, as you'll see shortly. When we do that, we have minus 8, minus 100 in the I direction, 30 minus 12 in the j direction. That gives us minus 108i plus 18j. Okay, now that's the displacement vector. To find the distance, we need to find the magnitude. Distance is a scalar, displacement is a vector. Displacement has both distance and direction, whereas we just want the distance part. To find that, we need to find the absolute value of the resultant vector, the displacement vector. When we find its absolute value, we get the square root of minus 108 squared plus 18 squared, which by calculator or some other method will give us 109.5 units. Okay, that is the distance between the two particles, whatever it is, meters, kilometers, whatever units we're working in. All right.